Okay, so let's keep going here. Looking at slope here, where is it negative, where is it positive? If you go to the next page, on the back, we've got a graph. Very nice graph, very big graph. Now read very carefully. Anytime I give you a graph, please read very, very carefully. If you read the directions below it, it says if the above graph is the graph of the derivative of f of x. Oh, see, this is not f of x. This is f prime of x. Then answer the following questions. This is f prime of x. Well, the first thing I'm going to do, if you go down, there's a little f prime of x down here where it says sketch the function. I would have done this anyways if they hadn't given me this. But since I give it to you, let's just use it. F prime of x. Now, the thing you need to look out for here are some critical values. Critical values are going to be values that are of importance to me because they change. Either they hit a zero or they change from increasing to decreasing. They're positive, they're changing positives to negatives. So if I look at this graph, since I'm dealing with the derivative, what I want to look for is where does this thing change from positive to negative? Because where the derivative is positive, I know my slope will be increasing. Where the derivative is negative, I know my slope will be decreasing. So I want to look at where does this thing change from negative to positive. It changes here at negative 8, and it also changes here at positive 12. So it changes at these two places. So I'm going to go down here and I'm going to put negative 8, positive 12. To the left of negative 8, our slope is negative. To the left of negative 8, we have a negative slope. In between negative 8 and 12, we have a positive slope. It goes above the x-axis, positive. And then after 12, it's a negative slope again. Oops, let me put that down bottom. So think about what that does for the actual graph. Just like we said on the front, if we have a negative 8 and a positive 12, where the slope changes from negative, which is decreasing, to positive, which is increasing, then back to negative, which is decreasing. Think about what that looks like. Think about what it looks like to go from decreasing to increasing. It looks something like this, wouldn't it? You'd go from decreasing to increasing. What would that make happen right here at negative 8? That would give you a minimum. What about going from increasing to decreasing? What would happen right here at 12? That would give you a maximum. So if you make this connection here, the zeros of your derivatives are going to be maximums or minimums on your actual graph. The zeros of the derivatives will be maximums or minimums on the original graph. The zeros of f prime of x will be maxes and mins of f of x. Alright? Now let's actually go up and answer some of these questions. This video is getting a little long. On what interval is the function increasing? So where is it increasing? Well, we already answered that down here. It's increasing where the slope is positive, between negative 8 and 12. Right? Between negative 8 and 12. Remember, intervals are always measured with your x value. On what intervals is the function decreasing? Well, that goes from negative infinity to negative 8 and 12 to positive infinity, right? It's decreasing where the slope is negative. The slope is negative down here. The slope is also negative over here. Keep in mind it's asking about the actual function. It's not asking about the derivative. It's asking about the function. Where does the function have a maximum? Well, it has a maximum at x equals 12. Where does the function have a minimum? At x equals -8. What degree will the function have? Ooh, this is fun. What degree will the function have? If you remember, I stated something on the last set of notes. I said the degree of the function is always 1 more than the derivative. If you look at the shape of the derivative here, what shape is that? Well, it's a parabola. And if that's a parabola, what degree is it? It's a second degree of 2. So what degree will the next one have, or will the original have? If the derivative is x squared, then the function itself will be x cubed. It's always 1 more. Remember, we also call that a cubic function. So let's actually graph it and let's see if that actually pans out. We're just going to do a quick sketch. Here's -8. Here's 12. And we said we had a minimum at -8 and a maximum at 12. And it changes from decreasing to increasing and increasing to decreasing. Notice there is no y scale here. That's how I know that this thing is going to be, it's okay. It's a sketch. There's no y scale, so it's just a sketch. So it goes from decreasing, bing, 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 to increasing, to decreasing. Okay. So again, think about, when you're going through this, think about what it means for the slope to be negative, decreasing, for the slope to be positive, increasing, and what happens in between those two. To go from decreasing to increasing, you have to hit a minimum. To go from increasing to decreasing, you have to hit a maximum. All right? We're going to get through a lot more of these here in the next few days. Just thinking about what the derivative means, what the slope of it means, all that stuff. It's going to be a good time.